Okay. The first algorithm is FCFS. Okay. Already data structure also we have discussed. FCFS means what? First come, first serve. Okay. So ready queue is there. Ready queue is there. So whatever job coming first or whatever process coming first in the ready queue will be allotted the CPU. That's all. P1, P2, P3, like that. If it is coming to the ready queue, whether it is a short process or long process or important process or unimportant process, nothing to bother. On what order it is coming to ready queue, that order it will be given the CPU. That is first come first serve. Okay. So first P1 arrives means P1 will enter the CPU. Consider this as CPU. P1 will enter the CPU. P1 will use CPU until its completion. Okay. Kindly remember that until its completion. So once P1 completed its work, then what will go? Then P2 only will go, P3 or P4 will not go because first come first serve. In this order only it is come. After completion of P2, P3 will go. Then P4 will go. Like that it will enter into the CPU. Okay. Process enter into CPU in the order of its arrival at the ready queue. So on what order it is arriving at the ready queue, in that order it will enter the CPU. Once it enters the CPU, it will complete its process. Okay. Order shall be determined by its time of arrival. So how I can determine P1 came first and P2 came first? The P1 arrival time is 10 o'clock. Okay, P1 arrival time is 10 o'clock. P2's arrival time is 10:05. So P3's arrival time is 9:55 means what? P3 arrived first. So automatically queue P3 will come. Okay, then P1 will come, then P2 will come. So on the based on the time of arrival at the ready queue only, I can order the process based on that order only it will enter into the CPU. In this scheduling, once process enters the CPU, it will exit only after its completion of the total CPU burst time. This is very important. By default, FCFS is a non-preemptive scheduling. What is non-preemptive? Current process will not get suspended on any reason. Okay, so by default, FCFS is a non-preemptive scheduling algorithm. Okay. Here, one important issue, I think this also we have already discussed. Just because of a single large process arrives before many tiny process, for example, P1 CPU burst time is 24, P2 2, P3 1, P4 2, P5 1, P6 1. So like this, in the order it is arriving at the CPU. Okay, in this order, it is arriving at the CPU. So what process will execute first? P1 will execute first. When P2 can get to the CPU, only after 24 seconds, it will get to the CPU. Okay, only after 24 seconds, it will get the CPU. Okay. Now if you calculate the throughput formula, number of jobs completed in a given period. For example, I am fixing a period as 10 seconds. So after 10 seconds, according to this example, how many jobs completed? No jobs completed. After 15 seconds, how many jobs completed? No jobs. After 20 seconds, how many jobs completed? No jobs. After 25 seconds, how many jobs completed? Only one job completed. Okay, at the same time, if the process arrives in reverse order, see this. Okay, P6 came first, then P5, followed by P4, followed by P3, P2, and P1. Consider, assume, if this process arrives in reverse order, first P6 came first. Okay, now you consider after 10 seconds, how many jobs completed? After 10 seconds, how many jobs will be completed? P6 would have completed, P5 would have completed, P4, P3, and so the result is 5. So if in this order, the throughput value is 5, but in the first previous order, the throughput value is 0. Even after 20 seconds, it is still 0. So what does it mean? Because of a very big process, so many small processes are in the waiting queue. Okay, so that is the one problem normally first come first serve will be, because according to rule, whatever the size of the process, we have to allot it first. Okay, consider it instead of 24 to 40 means what will happen? That's all. 240 seconds, nobody will complete this job. Okay, that is what we are referring as convoy effect. Okay, convoy effect. This is first come, first serve. Second algorithm is round robin algorithm, RR algorithm, round robin. See here, in order to avoid this difficulty, okay, in order to avoid this convoy effect disadvantage, here what we are telling is each process will be given a certain period of time mentioned by the time slice or time quantum to be executed in the CPU. Okay. Here, of course, we will consider the order in the queue, but we will not give the entire time. Okay. See, P1 is asking 24 seconds means no, I will not give 24 seconds. Instead, I will give some 2 seconds or 3 seconds. That will be fixed by time slice. Okay. So this round robin scheduling algorithm requires one more input called time slice, also referred as time quantum. Okay. If time slice value is 2, what does it mean? Each and every process in the ready queue at any given time will be given 2 seconds to execute in the CPU. Okay. So consider P1, P2, P3, P4. Okay, so first P1 will execute for 2 seconds. For example, P1 order total requirement and 4. Okay, P1 will execute. Even though if it is 24, P1 will be given only 2 seconds. Okay, as a first slot. Consider P2 order request is 2. So P2 also will be given 2 seconds. If P2 was given 2 seconds, that process is completed, correct? Then for example, P3 order request is 3. P3 will be given another 2 seconds. So leftover is 1 second. Remaining time is 1 second. Okay. P4 order request is 5. What will happen? P4 will be given 2 seconds. So its remaining time is 3. Then again, it will start from P1. Okay, P1 already executed 2 seconds, so 22. Now P1 will given another 2 seconds. So it will become 20. P2 is not required. Even though P2 allotted time is 2 seconds, it requires only 1 second. So within 1 second, it will complete its job. Then given to P4, 2 seconds it will execute, remaining is 1. Again, P1 will be executed for 2 seconds, 18. Now P4 only 1 second. So now no more process is there. Now entire CPU will be given to the P1 process. Okay, so whatever may be the request, the time allotted for each process is 2 seconds. What does it mean? We are considering all process as equal in the CPU point of time, so that no need to wait for big process to complete. Okay, I will get my own time at some duration. In this scheduling, one process enters the CPU, it will exit immediately after the expiry of its time slice. Okay, so time slice is 5 seconds means after 5 seconds, it will automatically exit by default if it is not yet completed. Okay, allotted time is 5 seconds, required time is 2 abdina. After 2 seconds, it will exit, that's all. Okay, as long as if the process still needs CPU, it have to exit for the next round. Okay, so when it will execute, when a particular process will exit the CPU, once the time slice expires. Okay, immediately after the expiry of its time slice. See here, by default, RR or round robin is a preemptive scheduling, correct? The FCFS by default is a non-preemptive scheduling. Once it enters the CPU, it will come out only after its completion. But here, but here Once enters the CPU, whether it requires or not, voluntarily it have to exit after 2 seconds. Okay, that is preemption. By default, preemption must be done if it is not yet completed. If it is completed, okay, automatically it will exit the CPU. Okay, this is round robin method. Third one is SJF shortest job first. Okay, shortest job first can also be referred as shortest remaining CPU time first. Okay, shortest remaining time first. That, like that also you can consider. Okay, SRT shortest remaining time. What time? CPU burst time. Okay, so listen carefully. At any given time, CPU will select a process from the ready queue that have smallest remaining CPU burst time. Okay, that have smallest remaining CPU burst time. Here we are having two types, preemptive and non-preemptive. Okay, consider the ready queue. First one is P1, its request is 3, P2, its request is 5, and P3, its request is 2. So at time T0, all three jobs are there in the ready queue. P1 requires 3, P2 requires 5, P3 requires 2. Okay. Now what will be considered by the CPU? At any given time, CPU will select a process from the ready queue that have smallest remaining CPU burst time. So in this process, which process is having smallest CPU burst time? P3 is having smallest. So P3 will enter the CPU. Okay, once P3 is completed, then P1 will enter. That is second smallest. Then P5 will enter. That is third smallest. Okay. So here, SJF with the non-preemptive means what? First P3 will enters. Once P3 enters, it will complete, then only it will exit. Before completion, it will not get exit. Like that. Then P1 will go. Surely it will complete its work, then only it will come out of the CPU. This is non-preemptive. Preemptive means what? See, listen carefully. One small example I am giving. At time 0, process P1, process P2, and process P3 is there. At time 2 or after 2 seconds, one new process is coming, that is P4. Okay, so P1 order CPU burst time is 10, P2 order CPU burst time is 15, P3 order CPU burst time is 20, and P4 order CPU burst time is 3. Consider this. Okay. So at time 0, how many processes are there in the ready queue? P1, P2, and P3. Among these three processes, what is the smallest process or smallest CPU burst time? P1 is the smallest CPU burst time. So P1 will enter. If it is non-preemptive, P1 will execute for 10 seconds. But if it is preemptive, see what will happen. After 1 second, CPU will see the ready queue. How many processes are there after 1 second? At the second 0, 3 processes is there. After 1 second, the same 3 process, no more new process. Among those 3, still P1 is smallest because P1 order requirement now becomes 9. But after 2 seconds, one new process arrives. After 2 seconds, na, the remaining time is 8. Okay, now after 2 seconds, one new process arrives, that is P4. P4 had a burst time and 3. Now 3 is compared with the 8, which is the smallest, 3 is the smallest. So P1 will be replaced by P3. Sorry, P4. Okay, P1 will be replaced by P4 and P4 enters the CPU. P1 will go to waiting state or ready queue. This is called a preemption. Okay, before the completion of P1, it gets suspended and new process is coming. Why new process is coming? That process is smaller than existing process. Okay, that process CPU burst time is smaller than the existing process. So it will be checked for each and every second. Okay, I have given in detail video lecture. Kindly spend some time and listen carefully. Okay. So SJF with the preemptive means in the scheduling, once process enters the CPU, it will exit immediately if you process with the less CPU burst time at the ready queue. Okay, any new process coming with the smaller CPU burst time, immediately current process will get suspended and the new process enters the CPU. And this process remaining time will be checked each and every second. Okay. And the last one, priority. So for each process is associated with one priority. As I told already, the smaller the number, the higher the priority. Okay. At any given time, CPU will select a process from ready queue that have higher priority. Higher priority means what? The smaller the number, the higher the priority. So one is the higher most priority and n is the lower most priority. Here also same concept, preemptive and non-preemptive. Same, the current process will suspended if any new high priority process arrives at the ready queue. That is priority with the preemption. Current process will not get suspended. That is non-preemptive. Okay. So here this point is very, very important. Shortest job first is a type of priority scheduling. So what priority there we are giving based on number in CPU, that is in shortest job first, what priority we are giving based on lower CPU burst time. So priority is given to lower CPU burst time. Okay. SJF is a type of priority scheduling where priority is the predicted next CPU burst time. Okay, with the smaller CPU burst time. That is the priority. Okay. The main issues with the SJF, that is shortest job first and the priority, is starvation. Okay. Starvation means what? To say it simply, endless waiting. Okay. Starvation means endless waiting. Endless waiting. What do you mean by endless waiting? See, listen carefully. If we allow preemption, according to shortest job first, which job will get the CPU? Yeah, job with the lower CPU burst time. Okay. Consider a job with the CPU burst time of 500 seconds. Okay, consider a job with the CPU burst time of 500 seconds. It is arriving at the ready queue after some time. Before that, already some processes are executing. Okay. So already assume three processes are there in the ready queue. This is fourth process. Three process P1, P2, P3 are smaller than P4. So P1 will execute. At the time of P1, P5 is coming, which is smaller than 500. So P5 will execute. P6 is coming, smaller than 500. So all the processes arriving in the ready queue is smaller than 500 means what will happen? Consider this process arrives at ready queue at 10 o'clock. Okay. So after 10 o'clock, so many new processes are coming. P6, P7, P8, up to P500, P1000. So many processes are coming. But all processes CPU burst time are less than 500. Okay. Now when P4 will execute, okay. Can you give any guarantee that P4 will execute surely at one point of time? Okay, only thing is if any job with more than 500 CPU burst time, then only P4 will execute. Can you give any guarantee that at some time one process will come that CPU burst time is greater than 500? No. Future we cannot predict. No. In future, I cannot say which job will come greater than 500. Okay, assume all jobs you are getting is less than 500 means P4 may not get a chance for another 2 hours or for another 1 day or for another 1 week or even for another 1 month. Okay, so when it will get a job, it will get the CPU. It will get only if all other process has completed its work and no other process to execute. That is one condition. Or another condition, greater than 500 arrives means that also we cannot give guarantee. Okay, as long as smaller processes are coming. This is what we are referring as starvation. Same thing is applicable to priority. Okay, higher priority job will be executed first. Okay, now assume one process P4, its priority is 100. Okay, so when P4 will get the CPU? only after executing process with the priority from 1 to 99. See, when it is executing priority with the 98, new process may come with priority 1, 2, 3, 4, 5. Again, process will go to P1, P2, P3, P4, P5. So we cannot give any guarantee that P4 will execute at some point of time because it is lower most priority. This is the problem of called what we are referring as starvation, also referred as endless waiting. This problem can be solved by using one concept called aging. Aging means after some period of time, for example, after 1 hour or after each 1 hour, operating system will decrease the priority by one of all the process available in the CPU. Okay, not only this process, of all the process available in the ready queue. So after 1 hour, it will become 99. After 1 hour, it will become 98. So what guarantee I can give? Purely you will get the CPU after 100 hours or after 99 hours. Because after 99 hours, this priority will become 1. So definitely that job will get the CPU because now the process is having higher most priority.